So technical difficulties. 1 second. All right, so next paper. Okay. So Suining, University of Connecticut, please take it away.
Everyone, so this is Suining here from the University of Connecticut. So it's my great honor to present our exciting work on the naturalistic e-scooter maneuver recognition. So it's a long title. I don't want to read it for you guys. So before we start these sections, I have a quick question. How many of you have rode scooters before? Raise your hand. Or maybe how many of you never rode it? Anyway, yeah. So how many of you have seen the scooters crash into the tree? Or fell down to the scooters? Someone, the riders fell off the scooters? Okay, so today we will talk about some of the work is try to see whether we can use some algorithms to learn how the riders use the scooters. So we have seen a kind of the proliferations of the micromobilities in the United States and also the Europe. So micromobility is referring to those kind of vehicles. It's like operating under 15 km per hour. So the representative modality would be like the scooters. It's very easy to maneuver and it's fast and can provide you the first mile or last mile connectivity. So it is kind of convenient modalities for you folks to ride it. And I believe in Cancun, I did saw some kind of scooters on the sidewalks. So here, this work is trying to focus upon a term that's called the rider interactions learning, or IRL for short. So it's basically trying to see whether we can understand and learn and recognize the e-scooter riders' maneuver behaviors. For example, like the left turns, right turns, accelerations, those kind of behaviors, which are critical for us to understand how the riders have maneuvered the scooters. And here we focus upon this term, the so-called naturalistic riding. It's trying to derive some insight from the e-scooter riders' behaviors during the everyday trips. So we don't want to control the kind of the entire data collections process. And our study motivation is focused on two parts. First is we would like to see whether we can capture the complex maneuver behaviors in a kind of the naturalistic riding settings. It is not easy because the scooter riders, they can maneuver the scooters in very different kind of ways, and the data collected will be kind of noisy and very difficult to analyze. And the second part that we would like to focus upon is whether we can perform a kind of the decentralized and adaptive rider interactions learning process for those emerging smart e-scooters designs. Because nowadays we have those kind of the e-scooter sharing platforms deployed in DC, in Colorado, Denver. So in those kind of metropolitan cities, we have seen those kind of sharing systems. Can we try to collect the data in a more decentralized way so that we can learn those behaviors based on those kind of embedded devices on the scooters? So this is something that we would like to explore from these studies. So we propose a so-called FCRIL. So it's a kind of federated maneuver identification systems with the contrastive e-scooter rider interactions learning. So it's a long title. So basically, yeah, we try to collect the data from multiple different riders, and then we perform federated and contrastive learnings to understand how those people have maneuvered those scooters. And this is a kind of system that we will potentially enable multiple different applications. For example, like we would like to enhance or improve the rider interactions, like promoting more safety measures and safe riding practices. And we would like to see whether we can reduce conflict and potential collisions risks in those kind of urban environments. So this is kind of the entire framework. So we collect the data, we perform the processings, and those kind of data will be, we have the kind of the normal pipelines about analyzing and process those features. And we have the rider interactions learning process is try to capture the features of the scooter's patterns. And our technical designs and efforts involve this basically 3 parts. First is that we provide a kind of the contrasted learnings for the maneuvers feature representations, try to distinguish different naturalistic riding maneuver classes. And we provide a kind of the decentralized rider interactions learning, and we have conducted extensive naturalistic riding data analytics and experimental studies. So this is a kind of the quick overview about our data collection. So we have conducted the test upon those kind of different scooters. So we basically collect the data using the smartphones as well as the standalone IMU inertial measurement unit sensors to collect how the riders have maneuvered those scooters. And we have basically studied and focused upon the maneuver classes like the left turns, right turns, and those kind of different behaviors. So we have collected more than 2,000 maneuver records for us to study. And we have conducted studies in terms of like a different data analysis. So we let the volunteers to ride the scooters in our campus environments and interact with very different kind of the traffic participants. And then we understand how those kind of the maneuver behaviors look like. So we also collect the GPS trajectories as well as the video frames as a kind of ground truth for us to label the corresponding maneuver classes. So here I probably will just quickly go through those model designs. We developed the contrasted learning to try to differentiate different kind of classes because those kind of the noisy measurement actually make it very difficult for us to discern. So we use the contrasted learning based on the cross-entropy losses. It's a kind of adaptive way to try to differentiate different classes and provide high accuracy. So we have also performed asynchronous federated learning mechanisms here. So the idea is that in the urban environment, probably it may not be so easy for you to collect all those data at once and then train the models. And because due to some kind of communication overhead and those kind of failures, so it may not be easy for you to train the models. So asynchronous way is you can store those kind of data offline, and then later you upload those data and then provide some kind of the additional model training process. So details can be referred to our papers. So we have conducted extensive studies. So these are some kind of accuracy that we can observe compared with the state-of-the-art algorithms. And we have also studied some kind of the different road surfaces. So there are some kind of different surfaces, for example, like the sidewalks, asphalt, concrete road, and as well as the red bricks. So we can see that the algorithms have different kind of performance. And later we will probably try to extend to different kind of the surfaces in the urban environment. And we have also studied like installations of different placements, locations upon the scooters. Actually, when I visited the cities of Detroit and many other metropolitan cities, so I have seen that those kind of the e-scooter sharing platform, they have already provided those kind of the places that you can fix the smartphone. So potentially, this kind of the sensor selections can be conducted in the same times. And we have evaluated different kind of the locations, and those may be helpful for the relevant service providers to understand the data. So we have also studied the asynchronous federated learning process, so the details can be referred to our papers. So the key takeaways here is that right now it's just exploration studies to extracting and learning and identifying the rider interactions. So this is a kind of the framework that can potentially become a kind of the building blocks for many futures systems, like understanding and learning how those riders interact with the complex urban environment. And this will help us to better improve the human-scooter interactions and reimagine those kind of different kind of interaction design. So I would like to thank my research groups here. So we are currently working and on extending the systems, and our teams is hiring. So I would like to acknowledge this research is supported by the Google as well as the NVIDIA. Thank you so much for attending my talk, and I'm happy to take any questions offline. And I will stay here until Friday. Yeah, thank you.
confusion or ambiguity for the day? Was it the placement of where, you know, the phones and was placed? All right, thank you. Is it working or not working?